Hi guys, okay, 12C part I. So this is actually quite a tricky question. It looks fairly straightforward. We have f of x and they say find f dash of x. But as you see, it's not a nice question. So this is taken from the formula booklet. This is the derivative of arc sine x, and we have arc sine of f of x. So we're going to have to use the chain rule because we're going to get the derivative of arc sine, and then we can get the derivative of this. So firstly, the derivative of arc sine is 1 over square root of 1 minus x squared. So the derivative of this is 1 over, let me do this, it's 1 over the square root of 1 minus x squared, but this whole thing is now x squared, so it's x squared minus 1 over x squared plus 1 squared. So as you see, it's just it becomes pretty quickly quite an annoying algebraic fraction in a root. Anyway, I have this, and I now need to times this by the derivative of what's inside the bracket, and that's going to be, well, I have to use a quotient rule over here, so I'm going to do u equals x squared minus 1, v equals x squared plus 1, u dash is 2x, v dash is also 2x. So then dy dx is equal to v u dash, so 2x times x squared plus 1 minus u, sorry, what did I do? V u dash minus u v dash, so 2x x squared minus 1 all over v squared, which is x squared plus 1 all squared. And this simplifies to, so this is actually 2x cubed minus 2x cubed, so they're going to disappear, which is nice, and we're going to have 2x here, so 2x minus 2x, which is 4x. So this whole numerator simplifies nicely to 4x, and it's 4x over x squared plus 1 squared. Okay, so I need to put that here, so it's 4x over x squared plus 1 squared. Okay, so here I have this annoying algebraic fraction. Let's try and sort that out. So I have this, okay, I need a big root. Now I want a common denominator, which is going to be my x squared. I need x squared plus 1 squared. So my common denominator is x squared plus 1 squared. And then that means I need to multiply this by x squared plus 1 squared. And this is fine, it's minus x squared minus 1 squared. Okay, hopefully that makes sense, guys. I've just turned this into this using common denominators, and then this is multiplied by 4x over x squared plus 1 squared. Now at this point I am going to flip this denominator because I don't like it. I don't like it two denominators here. So when you divide by a fraction, you flip and multiply. So what this becomes is actually the square root of x squared plus 1 squared, which is x squared plus 1. So it's x squared plus 1 over the square root of this x squared plus 1 squared, which is actually x to the, so this is x to the 4 plus 2x squared, so I'm multiplying out this bracket here, plus 1 minus x to the 4 minus 2x squared plus 1. Okay, so just to be clear, what I've done here, guys, is I've flipped this denominator. So this thing has now moved up to the numerator because I'm dividing by a fraction. But because it's squared and in a square root, I've just, they cancel each other out, if you like. So I'm left with just x squared plus 1 as the numerator. And then this bit here, I've just multiplied out to give me that. And this is all multiplied by, this has to still go across here. This is all multiplied by this, the 4x over x squared plus 1 squared. Okay, now this is equal to, well, this nicely cancels with one of these guys. Like there's x squared plus 1 and x squared plus 1 squared. So I'm left with, on the numerator, just this 4x. So I have 4x on the numerator. And then this actually works out quite nicely. My x to the 4 cancels with this x to the 4. My 1 cancels with this 1 because it's minus. So I'm left with the square root of 4x squared. So this is the square root of the square root of 4x squared. And then this is, so one of these has cancelled with this squared, if you like, so that cancels with that. And I'm left with here just x squared plus 1. Now this is very nearly what he wants. So he wants, what does he want? He wants the square root of x squared plus 1, and he wants a 2 on the top, but I'm going to get that because this is just 4x over, this is 2 times the square root of x squared times x squared plus 1, because the square root of 4 is 2, so I can take it out of the square root. And then this 4 cancels with this 2, and I'm left with 2x over the square root of x squared times x squared plus 1, which is what I think he wanted. 2x over x, the square root of x squared times x squared plus 1. Now you may ask, why doesn't he just say the square root of x squared is x? Well, in C part II, you'll see he has a reason for doing that. Okay, that's C part I.